Hi everyone, let's go ahead and get started. Welcome. Just a couple of things before we get into today's topic. One, the unit tests for homework 1 have been distributed. I put them in the repository yesterday, so I posted instructions on Piazza about how to grab those unit tests. Go take a look at that post on Piazza. Let us know if you have repository problems. We can help you out with those in office hours or online or whatever's easiest for you. And always keep in mind that worst case scenario, if your repository is on fire and you don't think you can put it out, just make a new one. It's fine. Just fork it over again and we will deal with it. What else did I want to... Oh yeah, the grades for the unit tests have not been posted yet, but they will be soon in the next day or two. I'm hoping to get those up on Canvas. I just don't have Canvas set up yet. That's why it's taking me a little bit of extra time to get those grades posted. So I'll have those up very soon. I'm trying to think what else. Does anybody have any questions on the homework assignment? I actually had a lot of people come to office hours yesterday. Yeah.
I noticed on the constructor for tuple disk script in the comments, it's like saying that we would expect that you're at least going to have one type in type array when it comes in there.
Sure.
But the method, the constructor itself doesn't throw an exception. So the thing, so my big thing, I'm wanting to guard against a user instantiating with nothing in the type array, like a null or an empty array. I would like want to put it like add a throw exception to it. But that bogs everything else up in the code, which currently. Yeah.
No, that's a good point. The constructor does not have an exception on it. Actually, it's very bad form, I think, for constructors to throw exceptions. Constructors really should not be throwing exceptions in most cases. So if you're worried about error handling in that particular case, what would be the best way to go about taking care of that? I'm not exactly sure. I think what you could maybe do as sort of a stopgap would be if you do get an empty type array, then make it not empty somehow. Just pick a default type and roll with it, right? Things are probably going to break later on in the code anyway if they gave you an empty type array. So, but constructors throwing exceptions is not good practice. Any other questions? I actually wanted to go over something just real quick before we get started today about the homework assignment. I got a question a lot yesterday from people just, trying to understand how the different parts of the homework assignment relate to each other. There's really a hierarchy of elements in this homework assignment. I talked about this a little bit on on Tuesday, but it does not hurt to review this since I was getting some questions, right? We've got a lot of different pieces, but really, if we think about it as a hierarchy, at the top level, we have the catalog. The catalog is... What's the catalog do for us? Can somebody explain? Yeah.
Contains a set of tables.
Contains a set of, so it's tracking what tables exist in the database. We actually have a name for this in the context of what we've been discussing in this class. Not data, but metadata. The catalog is the metadata. What tables exist? What columns do those tables have? Where are the files with the data that are backing those tables, right? That's what the catalog is tracking for. So the catalog keeps track of all the metadata, what tables are in the database. As we add more and more pieces into our database, the catalog is going to be tracking more and more things over time. But right now, all we really have is tables. That's it. Okay, and so then the catalog is keeping track of tables, and the tables are stored in files. So heap files are the next thing we're talking about. So a heap file, its job is to manage what? The pages, the heap pages. The heap file's job is to manage the heap pages. So the heap file will create new pages if it needs to. The heap file will find a heap page if you're looking for one, right? That's what the heap file is going to do for us. It's going to read pages from disk. It's going to write pages back to disk. It's managing pages. Yes?
Can we think of this as being one table per heap file, or is that a question?
No, one table per heap file. Exactly right. One table per heap file. Absolutely. Yes. So if you want to make a little, right, table. One table per heap file, absolutely. This is where that mapping takes place that I was talking to you about in class, right? Data is stored at a low level in a file, but people who use your database, they don't want to deal with files. They don't want to deal with binary data. That's really clumsy. That's really awkward. They want to deal with tables. So we're really trying to bridge that gap right now. We're building the low-level code that manages the files so that on the next assignment, we can actually query tables, something that's a lot more usable. That's where we're headed with all of this. Question?
Can you talk about the difference between
Page ID and table ID. So heap file is at the table level. The heap file manages pages. So pages are, one table is going to possibly have many different pages, right? It's going to span the whole file. So a table ID tells me how to get here, how to get to the file. I can go to the catalog, give it a table ID, and say, hey, tell me where the information for this table with this ID is. Tell me where it is. And the catalog will give me back the heap file, right? But then to actually access the data itself, the heap file is going to need to find the correct page. So within the file, within the table, there's going to be many pages. So they're just at different levels of the hierarchy. So the heap file manages heap pages. What's the heap page managing then? Tuples. Tuples. And you can put tuple descriptions in kind of the same bucket, right? They sort of go together. So we do have kind of a hierarchy here. If I'm going to use this database, which we're kind of looking ahead to homework assignment 2 a little bit, but if I'm going to use this database, I'm going to request a table from the catalog. And then I'm going to have some requirements that I want from that table. I'm looking for particular rows from this table. So the heap file will find the correct pages, or it might go through all of the pages, right? It might just do a scan, go through every single page, and then within the pages, I'll look at all the tuples until I find the ones that match the criteria that I'm looking for, package them all up, and that's my result. So this is sort of the high-level overview of how the pieces relate together for homework 1. If you read the instructions, I kind of have you bouncing around a little bit, starting with the tuples and then going to catalog and then doing heap file and heap page. You don't have to do things in that particular order. I actually tried to go from easiest to hardest. I think these 2 classes are the most difficult in the assignment. But if you want to take them down first, then you're more than welcome to do so. Any other questions about the assignment before I shift gears and get into today's material? Any other questions? All right, fantastic. So today we're going to talk about something a little bit different. We're going to talk about how to design databases. How to design schemas, actually, is a better way of saying it. So we're not going to talk about heap files today. Not anymore. We're done. Heap files, we're done with those. We are going to talk about tables, so we're going to move up the hierarchy even farther. We're getting away from the lower level stuff and getting closer and closer to being able to write queries and execute queries. It's important to understand how a database is designed and all of the different pieces and how the different pieces of a database interact with each other when it comes to writing queries. So if we're looking ahead a little bit into next week and the week after, we're going to talk about relational operations. That's really queries, right? And then you can see, if you took this class because you wanted to understand SQL, February 5th is the day for you, because we're going to talk about the SQL language in a lot of detail on February 5th in preparation for homework assignment number 2. So we're going to talk about designing databases today. If you're at a company, if you're working on an application, you think you want a database, the question is, well, how do I design this database? What tables do I need? How do those tables interact with each other? That's what we're going to talk about today. It's very, very, very important. Databases are not always known for being the most flexible structures in the world, meaning that if I design a database in a particular way and then decide the next day that, oh shoot, I actually should have made this table look this way, a little bit differently, it's not always easy to make those changes. A lot of times you have to throw away everything and kind of start over. So that's why this design process is so crucial. The design that you come up with for your database is probably going to be around for a while, whether you like it or not. Speaking from experience, right? People will stick with a poorly designed database because the effort it takes to redesign it is pretty high. And the effort that it takes to stick with a crappy database is relatively lower. So that's why it's really important to try and get it right as much as you can the first time. We actually just answered these next set of questions. How's data being stored? Well, we just went through the whole hierarchy of how data is being stored in our database, so I'm not going to rehash that all over again. Let's take a look at an example. I want to create a database. Here is the specifications for my database. This is actually a lot of detail. In the real world, you may not have this amount of detail available to you when you go out to create a database. You may have to go talk to people and figure out what all these details are and make these requirements yourself. That takes a lot of time. So for the sake of time, we're going to start with a pretty detailed list of requirements of what we want this database to contain. And so you can see it's a pretty straightforward database at a company that wants to track employee information. I want to track what departments exist and some information about the departments. I want to track what projects people are working on. So what employees are working on those projects. I want to track information about the employees themselves. How much money are they making? What's their address? Things like that. There's nothing too wild and crazy about this database, but the question that we now have is, how do we design a database in an intelligent way to reflect this information that we want to store? And in order to do that, we're going to create what's called an ER diagram. It stands for Entity Relationship Diagram. Those are the two main pieces of the diagram: entities and relationships. We've talked about relationships a bit. We're going to talk about relationships more today. Entities are, you can think of them as the objects, right, of our database if you're used to object-oriented programming. It's not quite a one-to-one relationship, but there's similarities there. So step one, if we want to create a database, we got to define our entities and our attributes. It's very similar to thinking about designing a class. What should the class name be, and what should the variables in that class be, right? Those are my attributes. And so how are we going to do that? I'm going to look at this list of requirements here, and any words that I see showing up a lot of times are probably going to become my entities. Not always, but that's a good rule of thumb. If I see the same word pop up many times, it's probably going to become an entity. So what's an example of something you think is probably going to be an entity in this particular exercise? Yeah. Department, for sure. Let's add that. And the way that we include entities in our diagram is very straightforward. We just draw a box around them. Nothing special. All right, what else? Yeah.
Projects.
I'm sorry?
Projects.
Projects, yes. Projects are also going to be an entity. What else we got? Somebody different? Some pretty low-hanging fruit out there, guys. Yeah. Employees. Anybody have any other ones they want to suggest? Yeah. Dependents. So kids, right? Your kids. Okay. Any other ones that people want to lobby for? Yeah. Locations, yeah, that's a good one. I think in a lot of cases, locations certainly would be part of considered an entity within a database. We see it pop up. Well, I see it pop up under projects. I guess you could argue that address is also a location. Although I think the problem with lumping those two together is that while I would probably expect a lot of projects to take place at the same location, I probably don't expect a lot of my employees to be living at the same addresses, right? There's not a lot of overlap between those two concepts. And this is the tricky part. So remember, we just did the first half of this step. We defined our entities. We still have the second half, which is defining the attributes. And so sometimes you're going to run into things like location where it might be able to go either way. Maybe it should be an entity. Maybe it should be an attribute. So how do you deal with that? This is always a tricky part of design when you reach these gray areas. The question here really is, do I ever expect that I'm going to want to have to query the locations by themselves? Am I ever going to want to just write a query that just asks questions about those specific locations? If the answer is yes, then that tells me that, well, that might be a good entity. If the answer is no, I do care about the location, but I'm always going to use it in conjunction with other data, like employee data, project data, then that's an indication that it should probably be an attribute instead of one of those entities. So while I certainly think you could include location as an entity, I'm going to follow my script and treat it as an attribute instead. So let's talk about attributes. I think we can see lots of different potential attributes up here. Anything basically that we haven't already declared as an entity is likely going to become an attribute. And so the way that we include those on our diagram, if I look at employees, right? An employee has an employee number, a name, an address, a salary. There's actually more information than that. The way that we include those on our diagram would be to draw bubbles coming off of the entity. Name. I'll put address out here. What's the other one? Salary. Okay. And we would do similar things for the other entities. So for departments, they also have a name, a number, and a location. Oops. Okay. Projects have a name and, or wait, was it a department that had? Yeah, department and projects have locations. I missed that earlier. Name. We don't need to do all of these. I think you guys kind of get the point. Name, birth date. Relationship. Okay, this is not an exhaustive list of attributes. I just wanted to make sure that we had a few attributes for each of our entities. Attributes are worth discussing in a little bit more detail, though, because not all attributes are created equally. Some attributes are different than others. For example, key attributes. Key attributes are any values that have to be unique for a particular entity. Do you see any of the attributes that we have included up here on the board that have to be unique for a particular entity? Go ahead.
Employee number.
Employee number. So any sane business is not going to give the same employee number to two different people, not on purpose anyway, right? In order to indicate that on our diagram, we just underline that. That is a key attribute. It has to be unique. Any other ones you think might qualify? Yeah. Department number. There's kind of a theme here, right? What about for dependent? Do any of these qualify? Not really. Not really. All of these things are not necessarily unique. And so what are we actually using these for? What are these ultimately going to become when we implement this database? Primary keys. They may not be the primary key, but they are what we would call candidates for the primary key. They're options that we might decide to use as the primary key. And so what this tells you is, for some entities, right, do we just not have a primary key for this entity? Is that just not a thing? The answer could be yes. I'm not required to have a primary key for every single entity, for every single table in my database. It's not required. But if I don't see a viable candidate here, I have another option. I can just make it up. Just make one. Just make a primary key for that particular entity. So, all right. I think that's good. Another kind of attribute that's worth discussing. Do I have a slide for it? I do not. Well, we already did that. Another kind of attribute that's worth discussing is called a composite attribute. That's an attribute that's actually composed of many different pieces, many smaller attributes. Do you see any examples of the attributes we have up here that could be broken down into smaller chunks? In the back? Address is the classic example of a composite attribute. So probably going to be street, city, state. I'd put zip code, or I can squeeze it up here. Zip. It's a classic example of a composite attribute. And composite attributes pose another question for us, actually. With a composite attribute, I have another decision to make. Do I store the composite attribute as one giant chunk, or do I store it as the component pieces? What do you guys think? For the sake of an address, right? Does it make more sense to store it as a giant chunk or as its component parts? Yeah.
I think you would decide if you ever were interested in retrieving just the pieces of the address. If you only want the address as a whole, then there's no point for composite.
Right. So if I'm ever interested in querying by state specifically, it would be to my benefit to break this off into its own piece, right? Or by city, or by zip code. It makes sense to break it off into its own piece. It's a lot easier, especially in database programming, to glue pieces back together and use them as a big chunk than it is to take a big chunk and split it into smaller parts. If I wanted to split, if I just had one big chunk of an address and I wanted to split it up into its parts, that becomes a string parsing problem, which, if you've ever done those, is a very annoying task to have to do. Sometimes necessary, never fun, right? So we're just going to avoid that situation by breaking it up into pieces from the get-go, storing each of those pieces individually. That won't always be true. Sometimes it'll make more sense to just store it as a big chunk. Any other things you see that might qualify as composite attributes? Yeah. The name. Yeah. Names are another common example. Do I ever want to just use the employee's last name or the employee's first name, or am I always just going to use it together as a big chunk? Again, it's kind of up to how you intend to use this database. If you don't know, smaller pieces are almost always going to be the better choice if you're unsure. For that same reason, it's easier to glue those pieces back together than it is to split them apart. All right. So we already started. Let's talk about relationships. So we've got the entity piece, and I've already sort of spoiled the conclusion of this diagram, but I think it's fairly obvious that these entities are going to become tables. They're ultimately going to become tables. The attributes then are going to become columns in my tables, right? That's where we're headed with this. So the other part of an ER diagram is the relationships. R is for relationships. These relationships are very, very, very important. Why? If I just made the database as it looks right now and I didn't include any relationships, what would I be missing? What would I not be able to do very easily? Yeah.
You can't look at one table and tie it in like find a relationship with another table. Like you can't look at employees and see what department they are, who their dependents are.
Exactly. I want to see not just employee information, but what department they work for, right? Without that relationship being defined between those two tables, it's not impossible for me to do that, but it's a lot more difficult. It's a lot harder. So those relationships being spelled out for me make it very easy for me to examine data from many tables at once. And so we talked about, I believe on the first day of class even, we talked about the different types of relationships that can exist in the database. What are the different types? Somebody give me one of the different types. Go ahead.
One to many, many to one, one to one, many to
One to many. One to many and many to one are the same. They're equivalent, just opposite directions. And then many to many is the other one that I care about. The relationship that shall not be named will not be discussed in this class any further, as far as I'm concerned. Although technically it does exist, depending on who you ask. All right, so we're looking for one to many and many to many relationships. And so the question is, what relationships exist and how do we classify them? Since it was already brought up, we'll start with the employee to department example. I think there's clearly a relationship there, right? Try and say it in English. Try and say the relationship in English. There's only a few different ways you can say it. One employee has many departments. Does that make sense? Not really. There might be some organizations where that's true, but I feel like in most organizations that's not true. So let's try the opposite. One department has many employees. All right, I feel better about that, right? That feels a lot better. So that's how I want to quantify the relationship. And the way that we include relationships on our diagram is with a diamond. And inside of this relationship, we describe it. We use, so notice entities are nouns, right? They're things, they exist. Physical things that exist. So the relationships are going to be verbs that relate these two nouns together. So works for, right? An employee works for a department. There might be a more concise way of saying it, but that's the one that I can think of. And we're going to include some more information about this relationship as well. I want to indicate that it's a one-to-many relationship. One department to many employees. So I'm going to connect these two together, and I'll put a 1 on the one side. And on the many side, there's a lot of different ways that people like to represent this. You might see a star, or you might see the letter N, or you might see something like this where instead of a line, it looks like a fork, indicating I've got many. They all mean the same thing. I don't really care which one you use, right? Just some indication that it's not the one, it's the many. All right? Any questions? Any questions? There's one other attribute that we need to discuss about our relationships, which is participation. It's possible that maybe, I don't know in this particular case if it's true or not, but it's possible that it's not required for an entity to participate in a particular relationship. An entity can be part of the relationship, but it doesn't necessarily have to be part of the relationship. Let me explain what that means in the context of this example. Would I ever expect to have a department that does not have any employees, that does not have any relationships over to the employees table? Is that ever a possibility? Okay, let's think about the opposite then. Would I ever expect an employee to not have a department, to just be kind of free-floating? Not really. So in order to illustrate that, instead of a single line, we're going to draw it as a double line. What the double line means is full participation. Every row in this table, right, every instance of this entity has to be related to, actually, I'm sorry, I should say this. Yeah, every department has to have at least one employee associated with it. Every department is going to take part in this relationship. Every employee is also going to take part in this relationship. Have to. Later on, as we do some more relationships, we'll see some examples of where that's not true. We don't have to participate in the relationship necessarily. It's optional. All right, so let's talk about it. What other relationships do we have in this? What other relationships? Between what entities? Yeah, go ahead. One employee can have many projects. All right, so we'll include a relationship here between employee and project. You said one employee has many projects. I want to be consistent. I'd say works on, right? And now we have the same question. Does an employee have to have a project? Is it required that every employee participates in a project? That's a trickier question, right? I think that's one that you could argue goes either way, and it really depends on what company you're talking about, the structure of the organization, right? Which one you choose. I think the opposite might be a little easier. Does every project need to have employees working on it? Yes. So that's definitely full participation. This one here, I think you could argue either way. Maybe it is, maybe it isn't. Maybe an employee doesn't need a project. They're just running a cash register or something. That's not a project. They're just pushing buttons, right? Maybe they don't need a project. Or maybe your organization is set up so that everything is categorized as projects. Every employee has to have a project. Context is super important. All right, what other relationships do we have? I know there's more. Yeah, in the back.
One employee provides for potentially multiple
Dependents. All right, let's do it. Provides for is what you said. I actually kind of like that. Provides. One employee can potentially have many dependents. Does an employee have to have? That would be real weird. No. No.
What if you're claiming yourself?
What if you're claiming yourself?
Well, yeah, because on tax returns, something that you claim yourself.
I am not a tax lawyer. I don't know the ins and outs of tax law. I view this as having either children or older, your parents maybe, who require your assistance. But you may have a point. I don't know how the United States government views that situation. I probably should, though, because I just had a kid, and now it matters to me. But we'll say, for the sake of this example, that employee does not necessarily have to have an associated dependent. But what about the opposite? No orphans going on here, right? Not in this example anyway. Every dependent has to be associated with an employee. Here we're presumably talking about benefits, I would assume, right? Health insurance, things like that. So they're going to want to know which employee to take the extra health insurance money out of their paycheck. There are other relationships here. I think we may move on for the sake of time. Are there any questions, though? Did you have a question?
Can we have like different ERs? For example, I don't like my analysis lab. We don't have like a relationship between employee and project, but we have a relationship between department and project.
Oh, okay. So you'd rather have this relationship go here instead? I think you certainly could do it that way. I think you could also do both. I think you could have this relationship here and also have another relationship between department and project. Maybe this department's in charge of the project, but this employee does not necessarily have to work for the department that's in charge of the project, right? It happens all the time. Even on campus, I work with people over in the electrical engineering department all the time on stuff, right? I don't work for the electrical engineering department. So it's possible that an employee can work on a project that's owned by a different department, meaning that both of these relationships are valid. Or, back to your original point, maybe just this one is enough to classify. It really, again, depends on where you're coming from. What's the context? How's your organization set up? You really want to make this match the real world situation as much as you possibly can. So don't do it just because it sounds good or it looks good. Do it because it matches what's actually happening in real life. Yeah?
Right now we have one employee maps with multiple projects. Could we have the opposite, or should we, where it's one project has multiple employees?
Ah, that's a great question. In fact, I may have missed that earlier when I was, yeah, in fact, I believe you're absolutely right. One project has many employees. I think that was a missed opportunity there. Thank you. So maybe this isn't a one-to-many. Maybe this is a, what would that be then? If it goes in both directions, one employee has many projects, one project has many employees. That's a many-to-many. That's how we define a many-to-many, right? So the way we would represent that is we'd put an M and an N. Everything else we discussed, though, remains the same. I think you're absolutely right. I think that's a good addition. Yeah.
I think my design is like to don't have this relationship between employee and project,
Okay.
but having it with department and project will overcome the situation where we have many to many relationships.
I'm not sure I understand. I mean, the biggest, so as a counter argument, the biggest argument against taking this out is if I want to know what projects an employee is working on, do I want to have to go through department to get there? Can I even figure that out by going through the department? Because remember, a department's going to have many projects. So if I just link an employee to a department and that department has many projects, do I know which one that particular employee is working on? Not easily. Not without this relationship. There's probably a way, right? I never want to say things are impossible and they can't be done, but this certainly makes it a lot easier to figure out, to answer that question. Maybe I don't care about that question. Maybe that's not a question that I ever expect to come up. It's not something I'm worried about. Well, then take it out. You don't need it. Yeah.
What about the location? We have a location on department and location for the project.
Yeah, for sure.
But they should like in any way match each other. So
Not necessarily. I mean, computer science department's over in Jolly Hall and we're standing here in Louderman right now. Right? So, in fact, I don't think there are any classrooms in Jolly Hall where the department is located. I couldn't teach a class in that building if I wanted to. So, again, though, it depends on the real-world system that you are modeling. If these two are always going to be the same, then you absolutely have a very good point, right?